So hello and welcome to another episode of Mathematics Tutorial. So I'm your tutor for today, I'm Armand. So we will now simplify conics. This is an easier approach on conics. So I hope you will stay tuned and watch the whole video, and I hope you will learn a lot. Okay? So what is a conic? So in mathematics, a conic section, or simply a conic, is a curve obtained as the intersection of the surface of a cone with a plane. So the three types of conic section are the hyperbola, the parabola, and the ellipse. So the circle is a special case of the ellipse, though historically it was called the fourth type. So we have here two cones placed together. So it is joined together at the tip, and you can see the different conics formed when you pass a plane through these cones. So the general equation of conics is given by ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So if b is equal to 0, it is parallel with the coordinate axis. If it is not equal to 0, or if there is a value of, if there is a term involving x and y together, so it is oblique with respect to the coordinate axis. In this video, I will only be teaching you conics that are parallel to the coordinate axis. So we will disregard xy, or the term involving xy. So let's just focus on x squared and y squared. So in some books, it is written as ax squared plus by squared. So don't be confused. It's just the constant or the coefficient. So you can write ax squared plus by squared plus dx, cx plus dy plus f equals 0. So that means that the equation given is parallel with the coordinate axis. Okay, let's start off with the circle. So the mathematical definition of a circle is the locus of all points which are always equidistant to a fixed point referred to as the center. So the constant distance is known as the radius. So you can form a circle by passing a plane perpendicular to the axis of the two cones. So the nearer you are to the tip, the smaller the circle forms. So the farther you are, the bigger the circle. So the locus means the set of all points. So the locus of all points that satisfies this given condition. So from a fixed point referred to as the center. So from this center, all these points that form the circle are equidistant to the center. So this is equidistant to the center, all these points. So they have the same distance from the center. So that constant distance is known as the radius. Okay? So all the points that form the circle, or all the points along the circumference, are equidistant to the center. So that distance again is known as the radius. So the general form of a circle is given by the equation ax squared plus cy squared plus dx plus ey plus f equals 0. So again, don't be confused with some books. They've written ax squared plus bx, c, d, and e here. So they are using the general form for conics that are parallel to the coordinate axis. Okay. For a circle, a is equal to c. So you should mind the values of a and c when looking at conics. Okay, so the coefficients of the x squared and y squared are very important in this topic I'm going to teach. So for a circle, the standard form is given by the equation, so with center at hk. So the standard form is x minus h squared plus y minus k squared equals r squared. So the standard equation with center at 0, 0, just replace h and k with 0. So you have x minus 0 squared plus y minus 0 squared equals r squared. So x squared plus y squared is equal to r squared. So normally you just memorize this one and just insert minus h and minus k. Okay, or this one, and if it's at 0, 0, so just remove h and k. Okay, so either of the two. And r here is the radius of the circle. You must pair x with h and y with k. So never forget that. So you don't swap them. So your answer will be incorrect. Now for a parabola, so the parabola is the locus of all points which are always equidistant. to a fixed point called the focus and a fixed line called the directrix. So a parabola is formed by passing a plane through any of the cones. So just to hit one cone. So you formed a parabola. So you have here the focus. Okay, so the parabola is again, this is the locus of all points which are always equidistant to a fixed point. So this set of points here, so just the same with the circle, so this set of points here satisfies the given condition here. So it is equidistant from a fixed point called the focus and the fixed line called the directrix. So the other parts of the parabola is this one is the latus rectum. It is equal to 4a, the vertex, focus. Yeah, that's it. So the general form of a parabola is given by the equation ax squared plus dx plus ey plus f equals 0. So the other one is cy squared plus dx plus ey plus f equals 0. So since you have two kinds of parabola, it's either facing up or down and the facing left or right. Now we have to talk about the properties of a parabola. So here is a parabola. So E is equal to 1.0. The length of the latus rectum is equal to 4a. The distance from the vertex to focus is, so here is the vertex and this is the focus, so that is a. Distance from vertex to directrix, so this is the vertex, this is the directrix, that is a. The distance from focus to ends of latus rectum is 2a. So this is the focus, this is the ends of the latus rectum, that is 2a. So the length of the latus rectum is 4a. So axis of symmetry or parabolic axis equation. So we have for horizontal axis y is equal to k, for vertical axis x is equal to h. So you must be familiar with all these properties of a parabola. So for a parabola, the standard equation with vertex at hk is given by, so again, as I mentioned earlier, we have opening up or down, left or right. So we have here for the opening left, quantity y minus k squared is equal to negative 4a times quantity x minus h. So for opening right, so just use a positive sign here and you get this equation. For opening downward, it is quantity x minus h squared is equal to negative 4a times quantity y minus k. So for opening upward, you have positive sign instead of the negative one. So in order for you to not get confused with the signs, just remember the coordinate axis. Okay? If it is opening upward, so for the coordinate axis, what is upward here? The positive y. So if we look at the equation, it is positive and it is y here. Next, we will go with downward. So this is in the Cartesian plane, this is negative y, right? So you have your negative and you have here your y. For opening right, this is positive x. Okay, so you have your positive and x. So for the one opening left, you have negative x. So just remember that the signs here are also relative to the Cartesian plane. Okay, so you won't mix the signs. Things are easier to learn if you learn to relate them to each other. Okay, so the signs here and the pairing of the terms are related to the Cartesian plane. Okay. Now for the standard form with vertex at 0, 0, so it's just easier. So if it opens left, it's y squared minus 4ax. If it opens right, it's y squared is equal to 4ax. If it opens upward, it's x squared equals 4ay. If it opens downward, it is x squared equals negative 4ay. So again, it's just the same rule. If it opens left, so the left of the Cartesian plane is negative x, right? So negative x. The right of the Cartesian plane is positive x, so you have positive x. So the upward or the upper portion of the Cartesian plane is positive y, so you have your positive y. The downward or the lower portion is negative y, so you have negative y. We have to look at first where is the squared placed. So if the squared is placed on the x, so it's either upward or downward. After that, you have to look at the signs. If it is positive, so upward. If it is negative, downward. So if it is placed on the y, so you have y squared. So you have two values of y. So it's either opening left or right. So you have to check if it is negative or positive. So negative if it opens to the left, and if it is positive, it opens to the right. Now we will deal with ellipse. So the ellipse is the locus of all points which sum its distances from two fixed points called foci is equal to the length of the major axis, which is 2a. You can form an ellipse by passing a inclined plane along one of the cones. So you can form it here, here, you can form it in this direction, or in this direction. So as long as it is inclined and hits only one cone. Okay, so this is the ellipse. So the general form is given by ax squared plus cy squared plus dx plus ey plus f equals 0. So it has the same general form with a circle, but a is not equal to c. I told you earlier to take note of the values of a and c. It will be very useful in dealing with conics. Okay, so we have here the ellipse, the directrix, latus rectum, focus, the vertices, center. Okay, on to the properties of an ellipse. I know this is a lot to take in, but you should be familiar with all of this to master conics. So in an ellipse, A is always greater than B. So A is the semi-major and B is the semi-minor. Okay, the eccentricity is equal to C over A. So the eccentricity of an ellipse is less than 1. So distance from center to focus, so center to focus is A times E. Distance from center to directrix is A over E. So center to directrix, that is A over E. So A is equal to C squared plus B squared. So the length of the latus rectum is 2B squared over A. So the major axis is 2A. If it is A or just B, that is semi-major or semi-minor. So the minor axis is 2B. Distance between foci is 2C. Distance between vertex is 2A. So this is the vertex here. So you have to be familiar with all of this again. Standard form of an ellipse with center at HK is given by quantity x minus h squared all over a squared plus quantity y minus k squared over b squared is equal to 1. So this is when the major axis is horizontal, or it lies along the x-axis. So when the major axis is vertical, so it is x minus h squared all over b squared plus quantity y minus k squared all over a squared is equal to 1. So this is when major axis is vertical. A lies where the major axis is parallel. So if it is parallel with the x-axis or the major axis is horizontal, the A is the denominator. Okay? So when the major axis is vertical or it is along y, so again, A is under y. Okay? Now for the standard equation, you center at 0, 0. So just remove h and k from the previous equation. So you have x squared over a squared plus y squared over b squared is equal to 1 when the major axis is horizontal. So when major axis is vertical, you have here your equation. Again, remember, when the major axis is horizontal, it is under x. Again, the major axis is along x, so it should be under x. Okay? So when the major axis is vertical, so you have here along y, so the major axis is vertical, so A should always be under y. So we will now proceed with the hyperbola. So I know this is a lot to take in, but this is just a refresher on the basics of the conics. So you form a hyperbola by passing a plane to the two cones. Okay, so this is the hyperbola formed. So this is your hyperbola. So the locus, again, this is the set of all points satisfying this condition given here. So this is the set of all points, this one and this one too. So the general form of a hyperbola is given by ax squared minus cy squared plus dx plus ey plus f equals 0. Cy squared minus ax squared plus dx plus ey plus f equals 0. So you have here a negative value of the c and the negative value of a. So now to the properties of hyperbola. Okay, so this is your hyperbola. This is the focus, the directrices, the vertex, center, the latus rectum. Yeah, that's it. So this is your major axis. This is your minor axis. So for a hyperbola, a is not always greater than b. So a squared is always the denominator of the positive term. Okay, so you have to remember this one. So the eccentricity is equal to c over a. So the eccentricity is greater than 1. So distance from center to focus is AE. Center to directrix is A over E here. Length of latus rectum, so 2b squared over A. Transverse axis is 2A. Conjugate axis is 2B. Distance between foci is 2c. Distance between vertices is 2a. So equation of asymptotes is y minus k is equal to b over a times x minus h. So again, you have to familiarize all these properties. So I will give you a pointer or tip on how to efficiently memorize these formulas or properties for the conics. So you have here the standard form with the center at 0, 0, and center at HK. So you have, again, you have major axis horizontal, major axis vertical. So for a major axis horizontal, you have x squared over a squared minus y squared over b squared equals 1. A is always with the positive term. When this is horizontal, or the major axis is horizontal, this is the x is positive. When the center is at HK, so you just insert minus h and minus k here. Okay, so again, when the major axis is horizontal, the x value of the term is positive. So we will move now to the major axis vertical. So for the major axis vertical, you have y squared over a squared minus x squared over b squared equals 1. So this is vertical, right? So this is along y, so y should be positive. And since this is positive, you should pair it with a. So you have to pair a always with the positive term. Or again, you should put a under the positive term. So when center is at hk, you have y minus k squared over a squared minus quantity x minus h squared all over b squared is equal to 1. Now here's a little tip. So did you know that ellipses and hyperbolas have almost the same set of formulas? So you have distance from center to the rectrix, so the same. Length of latus rectum, the same. Eccentricity, the same. Distance between foci, the same. Distance between vertex, the same. They differ only with the relation of A, B, and C. So for an ellipse, A is always greater, so that is A is equal to square root of C squared plus B squared. Now for a hyperbola, C is equal to square root of A squared plus B squared. So again, almost the same set of formulas, and just notice the difference with A, B, and C. So how to easily determine what type of conic using a given equation? The general equation of conics is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Again, some books only use plus by squared, so they disregarded this one, the term with xy. For a circle, a is equal to c. So if the coefficient of x squared and y squared is the same, so that's a circle automatically. For a parabola, so either a or c is present. If it's just x squared, that might be a parabola. If it's just y squared, so it might be a parabola also. So for an ellipse, you have a is not equal to c. So if both a and c is present but they are not equal, that might be an ellipse. But they should be the same sign. Okay? Same signs. So if a is positive and c is positive and they are not equal, that is an ellipse. So for a hyperbola, a is not equal to c also, but they are different in sign. So it's either negative, positive, or positive, negative. So again, if a and c is equal, so that is a circle. If either a or c is present, that might be a parabola. If a is equal to c and they are of the same sign, negative, negative, or positive, positive, so that is an ellipse. If a is not equal to c and they are different in sign, so negative, positive, or positive, negative, that is a hyperbola. So that's very easy to remember. Now we will apply the methods I've taught you earlier with a series of questions. So for the equations below, determine which type of conic they belong. Okay, and these are the equations. So you have x squared plus 4x minus 6y minus 14 equals 0. So notice that it's only x squared. So this is a parabola. So number 2, x squared plus y squared. So you have x squared and y squared, same sign, same value. So that's a circle. X squared minus 8x minus 4y squared minus 16y equals 256. X squared and y squared, not equal in value but different in sign, so this is a hyperbola. 2x squared plus 9y squared plus 16x minus 90y minus 239 equals 0. You have 2 and 9, same signs but not equal in value. This is an ellipse. So you have 5x squared plus y squared minus 3x plus 40 equals 0. So they don't have the same value, but they have the same sign. So this is an ellipse. So x squared plus y squared plus 10x minus 2y plus 23 equals 0. This one is easy, circle. So x squared plus y plus 2x minus 3 equals 0. Only x squared is present, so parabola. So 2x squared plus y squared minus 12x plus 14 equals 0. So you have 2 and 1. So different values, same sign, ellipse. X squared minus y squared plus 2y plus 1 equals 0. Different signs, hyperbola. X minus y squared plus 2y plus 1 equals 0. Only y squared is present, parabola. So that's very easy, right? So all you have to do is look at the values of a and c first. So it's just x squared and y squared. So again, if these are equal, circle. If only x squared or y squared is present, parabola. If both are present but different value, so same signs, that is an ellipse. Different sign, you have here a hyperbola. Now we will solve the center or vertex of a given conic. So for a parabola, find the vertex of the parabola. X squared plus 4x minus 6y minus 14 equals 0. So we have vertex at hk. So h is equal to negative the coefficient of x all over 2 coefficient of x squared. So just remember this formula. So that is negative 4 over 2 times 1. So we have negative, negative, coefficient of x is 4, coefficient of x squared is 1. So h is at negative 2. For the value of k, substitute x by h. So for the given equation, so you have here, then y is equal to negative 3, so that is your k. So the vertex is at negative 2, negative 3. So you don't have to really simplify the equation. So you just solve it using this method and you will get now the vertex. Now for a circle, so you have to find the center of the circle with the given equation. X squared plus y squared minus 6x plus 12y plus 9 equals 0. So for the value of h, you have negative coefficient of x all over 2 coefficient of x squared. So it's just the same with the parabola. So remember, always remember this formula. So you have negative coefficient of x is negative 6 all over 2 times 1, which is the coefficient of x squared. So if this is x, this is x squared. Okay? So you have 3. For k, this is y, and this is y squared. Okay? So you have negative, the negative value of 12. So this is 12, coefficient of y, all over 2 times 1. So this is negative 6. And voila, your center is at 3, negative 6. Easy. Now for an ellipse or hyperbola, it's just the same with how you solve the center of the circle. So find the center of the hyperbola, x squared minus 8x minus 4y squared minus 16y equals 256. So this is a hyperbola again, different signs. Okay. So you have again h is equal to negative, always put negative, then coefficient of x all over 2 coefficient of x squared. So you have negative 8 here, negative 8 over 2 times 1. So h is equal to 4. K is, again, this is y. If this is k, this is y, and this is y squared. So you have negative 16, coefficient of y, all over 2 times negative 4. So this is negative 2. So the answer is 4, negative 2. I will teach you how to easily transform a given general equation to a standard equation for any given conic. Okay, so let's start off with a parabola. So convert the given equation x squared plus 4x minus 6y minus 14 equals 0 to the standard form. So this is the equation I gave you earlier when we solved the vertex of the parabola. So we already have the vertex at negative 2, negative 3. Since this is x squared, and if you transpose y here, so y is paired with a positive value. So the applicable standard form to this one is x minus h squared is equal to 4a y minus k. So we have here 4a is equal to, or this is the latus rectum, is equal to the absolute value of coefficient of y all over coefficient of x squared. So we have here 6. So latus rectum is 6. So when we substitute the given equation, this is h, this is k, and this is 6. So just substitute all the given, and this is now your standard form. So that's very quick, right? So first you locate the vertex, then find the relative standard form. So this is the standard form that will fit the given general equation. Then solve for the latus rectum, or the value of 4a. Now you have your latus rectum. Substitute all the given to the standard form. Is it axis vertical or horizontal? Is it upward or downward? So this is upward and this is axis vertical. So you have two values of x. So this is x squared, and this y here is paired with positive coefficient. So you have a value of positive y. So you have an upward, facing upward parabola. Now for a given circle, so convert the given equation, x squared plus y squared minus 6x plus 12y plus 9 equals 0 to the standard form. So this was the problem we solved earlier when we solved the center of the circle, right? So we have now the center at 3, negative 6. So the standard form is given by this equation. So we have the value of h, the value of k, but we don't have the value of r. So what is now the value of r? So r squared is equal to the absolute value of this equation. So just put this whole equation here inside the absolute value and use the values of h and k for x and y correspondingly. So just direct substitution, we have 3 squared plus negative 6 squared minus 6 times 3 plus 12 times negative 6 plus 9. So we have 36. So the radius is 6. So substitute the values of h, the value of k, and the value of r. We have the answer as quantity x minus 3 squared plus quantity y plus 6 squared is equal to 36, or 6 squared. I just emphasized 6 squared here for the value of r. So this is the simplified approach on converting a given general equation to the standard form. Okay? So now we will transform a given ellipse to the standard form. So convert the given equation to x squared plus 9y squared plus 16x minus 9py minus 239 equals 0 to standard form. So the center is at negative 4, 5. This is a little tip. If a is less than c, the axis is horizontal. If a is greater than c, the axis is vertical. So from the given equation, we have a is less than c. So therefore, the standard form that we will use is this one. So we have here x minus h squared all over a squared plus quantity y minus k squared all over b squared equals 1. So the axis is horizontal, therefore a should be under x. Okay, so this is both positive since this is an ellipse. So now we have the value of h and k. So but we don't have the value of a and b. In the previous example of a circle, we solved for the value of r squared by using the given equation. So now I will introduce you to a constant. So this is u. So we will equate u with this given equation here. 2x squared plus 9y squared plus 16x minus 9py minus 239. So this is u. Okay? So solve for u using the values of h and k here for x and y. So u is equal to 496. So now the value of a, or a squared, is equal to the absolute value of u all over coefficient of x squared. So you have 496 over 2, that is 248. So the value of a squared. So for the value of b, so a here is paired with x, since a here is also paired with x. So the value of b is paired with y. So value of b here is paired with y. So this is equal to 496 over 9. So you have here, substitute the given values to the standard form. You have h, k, a, and b. So now you have your answer as here. This is the value of your a squared. This is the value of your b squared. So just remember this one. So you have to check first if it is axis horizontal or axis vertical by comparing the values of A and C. Then you solve for U. To solve for the value of U, you should use this given equation here. Substitute the values of H and K for X and Y correspondingly. After getting the value of U, you have A squared and B squared. So if A here is paired with X, so you should pair it also with X. And if B is paired with Y, you should pair B here with Y also. Solve for the value of A squared and B squared and substitute all the given values or all the values to the standard form. So you have here your standard form, okay, or value of A, and this is the value of B. Okay, so that's very easy, right? For some, maybe this is new to you, so you just have to be familiar with the process. Again, once you learn something new, you have to repeat it until it sinks into you, okay? So you have to repeat and repeat until you master the process. So we'll now proceed with the hyperbola. So the method in solving or in converting the given equation for a hyperbola is just almost the same with the ellipse. So we have here the equation x squared minus 8x minus 4y squared minus 16y equals to 256. We will have to convert this to standard form. So the center is at 4, -2. So you already know how to solve the center. So the center is at 4, -2. If A is positive, the axis is horizontal. If A is negative, the axis is vertical. So therefore, the axis is horizontal since the value of A is 1. So you have here your equation, standard form. So when the axis is horizontal, so the value of x or the term involving x should also be positive. Okay, so -4y. And if you remember the property of hyperbola, a squared is always paired with the positive term. We have the values of h and k, but we don't have the values of a and b. So again, the method in solving for the ellipse is just almost the same with the hyperbola. So we will now use the arbitrary constant u. So u is equal to the given equation. So x squared minus 8x minus 4y squared minus 16y minus 256. So just transpose this one, minus 256. So solving for u using h and k as x and y respectively, we have u is equal to -256. We have a squared is equal to u over coefficient of x squared. Again, a is paired with x, so use a and x together. So we have -256 over 1. So that is 256. Absolute value, so this is positive. So b is paired with y here, so you should pair with b with y also. -256 over -4. Coefficient of y squared, right? -4. So we have 64. So the standard form, so substitute a squared and b squared here, you have x minus 4 squared all over 256 minus y minus -2 quantity squared all over 64 is equal to 1. So the answer is equal to this one. So x minus 4 squared all over 16 squared minus quantity y plus 2 squared all over 8 squared is equal to 1. So you can express this one as 256 and this one as 64. So I just emphasized 16 squared here for the value of a and 8 squared here for the value of b. In case if you're going to solve for the lengths of the transverse and the conjugate axis. Okay, so that is very easy and simplified. So again, I hope you learned a lot. I hope you practice what you learned. So that's it. So thank you for watching the video, and I'll leave you with this quote here. So the key to mastery is repetition. So I have to highlight this one. Repetition. Okay. So the key to mastery is repetition. So you have to practice what you've learned. So you have to repeat it and repeat it until you master it. Okay. So that's what I do most of the time. So if I learn something new, I solve all the problems related to it, and yeah, that's how you master the technique. So that's it. Thank you for watching, and this is your tutor for today. I'm Armand, and hope I see you again in the next video. Don't forget to like and subscribe. Okay, thank you for watching everyone, and hope you have a good day.